We have been seeing increasing occasions of heavy rain that eventually cause landslides and floods. Many lives are still being lost in many parts of the world, because of these natural disasters. Although early warnings are given via weather forecast, people tend to think I am still okay, when in fact risk level for him or her is actually rising. In order to stay away from risk zones and protect your lives, you must have more accurate information about the risk and evacuate, if necessary, as soon as possible. In this video, I would like to introduce, to you, a method for visually informing people about water level rising within ground or in river. It is very important that you know about the water level rising since it occurs before landslides or floods, and therefore knowing that would give you time to evacuate early enough to protect yourself. A common way for measuring the water level is by using a water pressure sensor installed within the ground, or a water level detection sensor at the river. Those sensors are usually sophisticated electrical devices that need to be installed properly by professional engineers at a reasonable cost. However, the reality we have to face is that we do not have sufficient budget to install such devices at as many places as we would like. This situation is the same everywhere in the world, and we need to come up with an alternative way to measure the water level and quickly inform people about the measured results. And do not forget that this new method must be available at low cost. I think you have seen a pipe under your kitchen sink that looks like the letter S. And this S-shaped pipe is going to play the key role as a low-cost device that can measure the water level and visualize its change on a real-time basis. Imagine a transparent pipe which looks like the letter S standing upright. Its lower end is at the distance d from the ground surface, and is still above the underground water level shown as blue area. The air pressure in the pipe is the same as the atmospheric pressure P0 at this stage. The curved zone as high as alpha is filled with red ink. And the distance of a traced line, shown as a blue line, measured from the bottom of the pipe all the way to the left top of the red ink is indicated as L. As the underground water level rises, the water goes into the pipe as high as X, pressurizing the air in the pipe, and pushing the red ink. As a result, the pressure inside the pipe increases as much as delta P, and the red ink goes down as much as H on the left, and goes up as much as H on the right, respectively. Assuming that there is no temperature change in this process, the distance of water penetration into the pipe, X, can be calculated from the Boyle-Charles's law. The value of X can then be used to find the distance from the ground surface to the top of underground water, namely W, can also be calculated. Now, let us watch the videos of the experiments in which this principle is demonstrated. In these videos, the ground is not modeled, but the fundamental behavior of water and air is correctly expressed. As the water is poured into the first cylinder, you can see that the red ink starts to respond as predicted by the principle of physics explained before. Water is now poured into the third cylinder. Just like what has happened to the first and second cylinders, the red ink for this unit correctly responds to the rise of the water level in the cylinder. You can also recognize that the magnitudes of the red ink movement for the three units are different according to the differences in the final water tables. As you have just seen in this series of experiments, changes in water table, whether that would be happening in the ground or in the river, can be correctly measured and visualized by using the principle of nature just by using a cleverly designed pipe. Let's see another illustration of a case in which water level of a river is monitored by the same method. In this state, the positions of the red ink are unchanged from the initial conditions since the water level is still low. As the water level rises, the river water gets into the pipe, and then the red ink shows that the risk is approaching to you. Since this information is updated on a real-time basis, you and your friends could evacuate to safer areas in advance. The monitoring system of this nature could be set up at a reasonable low cost, since no sophisticated devices or hardware systems are required. The On-Site Visualization Consortium will continue to produce life-saving technologies that are affordable, convenient, easy to understand, install, and manage to protect your life.